here. So in chapter 9, we're only going to do a couple lessons. We did 9.2 with the piecewise functions, and all we're going to do with that is what you did there. It's just being able to plug numbers in and use them. And then we're going to do 9.4, which is operations with functions. And so we're going to be doing most of what we're doing today is going to be similar to basically the first lesson we did in chapter 6. Just adding, subtracting, multiplying, and dividing polynomials. And then we're going to look at what's called composite functions, and that's a little bit different, but it's not a big deal, but some people get it confused with multiplication because of the way things are written. And so then we're going to do 9.5, which is some more work with inverses. And then we'll take a quiz over those 3 lessons on Monday, and then on Tuesday we're going to do 9.6, which is just some work with our calculator. So, all right, so first of all, here's our notation we're going to be using for adding, subtracting, multiplying, and dividing functions. Okay. So we have 2 functions, or you could have 3 or more, but they're written as like f of x and g of x, and so we're going to look at f plus g of x. So all we're doing is just adding those functions. Or f minus g of x, subtracting them. If they're written next to each other, that means we're multiplying. And if they're written as a fraction, that means we're going to divide. Now the important thing to remember about when we're dividing is that you have to pay attention to where the denominator equals 0 and where it's undefined. Okay, so the first one here is we're just going to take these 2 polynomials. F of x equals 4x squared plus 3x minus 1, and g of x equals 6x plus 2, and we're just going to add them. So just a matter of adding the like terms. And so how you write this is completely up to you, and one of the things that I got used to doing is writing them when I can, is writing them vertically, so that I can just line up my like terms to make that easier. So 4x squared plus 9x plus 1. When we subtract them, we need to make sure that we subtract correctly. And you got to make sure you have the right order too. So it does say f minus g. So remember that when it's subtraction, we are actually talking about taking this whole polynomial and subtracting that whole polynomial. And then when we're subtracting the polynomial, we have to do what? Okay, all right, change the signs of the second one. So 4x squared plus 3x minus 1. And now we're going to subtract 6x and subtract 2. So I could even write that vertically if I want to. So just some work with polynomials similar to what we've done before. Right? Adding and subtracting them to start with. And the same thing when we are multiplying and dividing. Is similar to when we've multiplied and divided polynomials before. So I'm going to do f times g. All right, so you can set this multiplication up the way you want to. Do it horizontally, do it vertically, make a table. Okay? Whichever method you would choose to do. Or you could multiply them horizontally and write them vertically, which is one thing I've done too. So we'll take all three of these in the first one, multiply them by 2x. So 12x cubed minus 2x squared minus 24x. And then multiply all three of them by -3. And then I'm going to put the like terms underneath for my simplification purposes. So -18x squared plus 3x plus 36. And then just combine the like terms. All right, so we divide them, write the one over the other. So what do I do to attempt to simplify this one then? Okay, so the first thing we've got to do is factor. All right, if we can factor the numerator, factor it, hopefully it has the same, one of the factors is 2x minus 3, so I can cancel them. And then we just have to remember to determine where it's undefined at. All right, so I'll give you a minute to. So when I do my factoring, all right, then we can cancel the 2x minus 3's. And then x cannot equal where the denominator is equal to 0. So that means I've got to take the 2x minus 3 and set it equal to 0 and solve. So we have to add 3 and then divide by 2. So x cannot equal 3 over 2. Or if you desire, 1.5. So let's do the dividing one here. All right, composition of functions. Another function operation uses the output from one function as the input for the second. Okay, that's called composition of functions. So it's written in a couple of different ways. You have f circle g of x. Okay, all right, and whichever way you see this, it's just read as f of g of x. And if g goes first, then it's g of f of x. Right? That's not fog. Right? Not that hazy stuff in the morning. Right? That's f of g of x. Just a little circle. So when you're doing composition of functions. That means we're taking all of the one function, okay, which I call the middle one, and we're going to replace the other function with it. Okay? We're putting it in for the other function. So if it says f of g of x, right, first we're going to find out what g of x equals, and then we're going to plug that into f of x and find the number there. So here they give us this little chart here, and they say, okay, so if x is 1, and I want to find f of g, I'll find out what g of 1 is first, and then I'll find out what f of that number is. So first they're going to do g of 1, they get 4. Then when they do f of 4, they end up with 8. And yeah, these are just arbitrary numbers that they're using though. But so we stick it in for g first, and then the answer we get goes in for x. Because if you think about it, we talk about these as f of x or g of x. And what's actually happening then is we're taking the g of x and we're sticking it in there inside that parentheses. So we're replacing this x here with the whole function g of x. And first of all, we're going to look at it just using numbers, and then we're going to look at it by replacing it with the actual function itself. So the one thing I always think of it as is that we're going to work our way from the inside out. Start in the middle and then go outward from there. All right? And the one thing is, the caution is, do not mix that up with multiplication. F times g of x is not the same as f of g of x. Okay? So make sure you don't mix them up. All right, so evaluating composite functions. F of x equals 2 to the x, and g of x equals 7 minus x. And we want to find f of g of 4, and then do g of f of 4. So the first thing we're going to do is we're going to do what's inside this parentheses first. So we're going to do g of 4 first of all. So g of 4 equals 7 minus 4, which is 3. So since this part here inside equals 3, we're now going to do f of 3, because I just replaced the g of 4 with its value, which is 3, and then we'll do 2 to the third power, which is 8. So we start on the inside, simplify that portion or evaluate that part, and then plug that answer in for f or g, whichever one it is. So over here then, because it says g of f of 4, we're going to find f of 4 first. So I replace x and f of x with 4, and we get 16, 2 to the fourth power. Then, so now then, since f of 4 equals 16, we want to find g of 16. We get negative 9. So my final answer for these two problems is negative 9 and 8. So you're working your way from the inside out, we find what's in the middle first, and then we plug that number in for that answer. Okay. All right. So you can also use algebraic expressions as well as numbers as inputs into functions. So what this means is that instead of working with just numbers like we were doing here, plugging numbers in and evaluating, we're going to take the whole function and plug it in for x. So when this says f of g of x, that means then we're going to take this whole thing here and put it in there for x. We're replacing all the x's in f of x with the function that is g of x. So we're not putting a specific number in there, just taking the function itself. So we're going to replace this x squared with this whole thing is going to go in there. So it's x over 1 minus x squared minus 1. And this one we're just going to leave like that. Okay. Now it says state the domain. So is it all real numbers? Well, I'm dividing, so I have to check to see if it's equal to 0 in the denominator anywhere. Okay. All right. And this would be equal to 0 in the denominator at 1, so x cannot equal 1. All real numbers except for 1. All right, so then we're going to take it the other way. Find g of f of x. So this means that we're going to take x squared minus 1, and we're going to replace this x with it and that one. So anywhere there's an x, I'm putting in the other function. So this would be x squared minus 1 in the numerator, and 1 minus the quantity x squared minus 1 in the denominator. And then we're going to simplify the fraction. Now this one's a little bit trickier as far as where the denominator equals 0 then. Because now we have to go from the end here, negative x squared plus 2, and find out where it's undefined. So that becomes a little bit more difficult, but we can do it. So negative x squared plus 2, we want to know where does that equal 0? So I'll add x squared to both sides, and we get 2 equals x squared. And to find x, we'll take the square root. So x cannot equal plus or minus the square root of 2. And we're solving an actual equation, so we get plus or minus. Don't forget that. So when we're just using functions themselves, we're taking the one function and replacing it with the other function everywhere that there's an x. All right, so if we go back here and use this one just for a second before we do the check it out. Right? So in this case here, if I did f of g of x, it would be 2 raised to the power of 7 minus x would be f of g of x. Okay, because all I would do is put the 7 minus x in for x. And the g of f of x, I would replace this x with 2 to the x, and it would just be 7 minus 2 to the power of x. So we replace the x in one with the other function. So do both of these two. Now, a couple people did the same thing. Now, this is
You did it?
well, yeah, I just did them last night, so
Oh, wow.
it's a true statement. Okay, it is undefined that x equals 6. But in this problem, the answer is 3. If I would have gotten 6 for my answer, then there would be no solution. Okay, and it's the same one down here. Because you got 7 for an answer, and I plug it back in, it doesn't work. So that one, there was no solution. So you did those two just the opposite then. Okay. And then there's always a second piece. So you have to increase your window on your calculator to find it. Yeah.
That was the fastest I've ever
Gotten
seen someone grade a test. So, you know.
Well, I graded them last night. I got all the answers in my head, and
Do you remember the answers still?
no, most of them, but my key's right there, so it didn't take that long. I'm just amazing like that, Mackenzie.
Yeah.
What time's practice tonight?
5 to 7.
Oh man, you still can't come watch my team play. I'm gonna get my first win against Napoleon ever tonight in basketball. Or no, well I should say that in middle school basketball probably. I don't think I've ever beat them in middle school basketball. What? Not against Napoleon, did we? No.
What lesson are we on?
9-4. We're not doing 9-1. And those problems yesterday were from 9-2. We're going to do 9-5 tomorrow. We'll have a quiz over 2, 4, and 5 on Monday, and then do 9-6 on Tuesday. What do you need a note card for? This is really short. If Daniel uses note card wisely. No, it's not. It's the same size. I can give you a smaller one if you want. I got smaller ones. What? Kind of cold in here? You should be up moving around. All right, so the toughest part on these two is getting the correct domain. All right, so let's see how you did. All right. So f of g of x, 3 times the square root of x plus 2. Did we get that? I'm seeing a lot of erasing going on. No, Jasmine? All right, so let's look at it. So we're going to take square root of x plus 2 and put it in for x. So we have 3 times the square root of x plus 2, and then we have the minus 4. Okay, sometimes people forget that minus 4 there. And that causes a mistake. So we distribute to 3. We get 3 square roots of x plus 6 minus 4. And 6 minus 4 is 2. So 3 square roots of x plus 2. Now, we can't take the square root of a negative number. So that means that x must be greater than 0, greater than or equal to 0. Okay, greater than or equal to 0. Okay. For g of f of x, we have the square root of 3x minus 4, and then the plus 2 is on the outside. Can we simplify that? And the answer is no, you can't. All right? Even though there's a 4 under the radical, you still can't pull that out and make it a 2 because it's subtracting, not multiplication. If this was 3x times 4, then yes, you could. But would it be in 3x minus 4? That's all one piece together, and I can't separate it like that. So this is the answer. And to find the domain, 3x minus 4 must be greater than or equal to 0, so I have to solve that inequality then. Because I can't take the square root of a negative number, so I have to write this as an inequality and then solve it, and we get x is greater than or equal to 4/3. So make sure that if you have problems like this, make sure you definitely have a clear ending to your radical before that plus sign, so you have space there. Okay.